So a quick recap, circles we have studied. We had studied about the chord. Chord is nothing but a line that touches the two, that has endpoints on the circle, right? On the surface of the circle, a line that has endpoints on the surface of the circle. And we had studied about the angle subtended by a chord at a point. It has two theorems based on this. We have two theorems. First theorem is equal chords of the circle subtend equal angles at the center. The second theorem is, what is the second theorem? Do you remember? Please tell aloud. Is it the converse of theorem number 1?
Yeah.
Yes, if angles subtended by the chords of the circle are at the center are equal, then the chords are equal.
Chords are equal.
Yes. Theorem number 3, beta. What is theorem 3?
The perpendicular from the center
something? Yes.
to a chord bisects the chord.
Bisects the chords into two. And what about the theorem number 4? It's
The
just the
line
converse of theorem
drawn
number
through the
3.
center
Yes.
of the circle to bisect the chord
Yes.
is
Excellent.
perpendicular to it.
Excellent, mashallah. Very good. So that was the theorem number 4 and 3. And what about theorem number 5, beta?
Equal chords of circle are equidistant from the center.
Excellent. Excellent. This is theorem number 5. And what about theorem number 6?
Chords equidistant from the center are equal in length.
Excellent. Very good. What about theorem number 7?
The angle subtended by an arc at the center is
Excellent. Theorem 7 is based on arc, right? Yes, yes, yes. Very good. Angle subtended by at the center of the circle is twice of the angle subtended at any other point on the circle, right? On the surface of the circle. That was theorem number 8. So we had some problems based on the previous topics. We also solved all of this, and then we just checked the theorem number 7 as well as 8, and we have some properties of the circle. Equal chords are congruent to the circle, and more properties we have. And after that, we have studied theorem number 7, and then we had studied theorem number 8. What is theorem number 8, beta? Angles in the same segment
are equal.
Yes, this is theorem number 8. What is theorem number 9? It is converse of theorem number 8. What is it, Laiba? This is a bit long, but it is actually the converse of theorem number 8. It states that if 2 points are subtended or subtends equal angles at 2 other points lying on the same side of the line containing the line segment, the 4 points lying on the circle, they are concyclic, okay? They are not collinear, they are concyclic. All the points lie in the same circle. So that was theorem number 9, theorem number 8, 9. And there is some property of a circle that is nothing but angle in a semicircle is a right angle, okay? We just know that already. And then there is a new theorem for the cyclic quadrilateral. What are cyclic quadrilaterals, Laiba? Okay, what are cyclic quadrilaterals? A quadrilateral ABCD is called cyclic if all the 4 vertices of it are on the surface of the circle, right? So this is a cyclic quadrilateral. What are the 2 major theorems in cyclic quadrilateral? Very easy. Please tell. Laiba? The sum of the pair of the opposite angles of the cyclic quadrilateral are equal to 180 degree, correct? And what is the next theorem? Theorem number 11, beta? It's just the converse of this theorem. If the sum is 180 degree, then all of these are said to be in the same circle, or they are concyclic, correct? Theorem number 11 is converse of theorem number 10. It states that the sum of the pair of the opposite angles of the quadrilateral is 180 degree, then the quadrilateral is cyclic. Fine. So we will study the example problems on all of the theorem number, almost theorem number 7 to theorem number 11, right? We have studied 11 or 12 theorems. Please tell.
11.
The circles chapter has 11 theorems. Okay, these are the 11 theorems that we have studied in the chapters called circles. Fine. So these are the 11 theorems. Now the example problems that we are going to study is based on theorem number 7 to theorem number 11. Okay, because we have already discussed till theorem number 6 and we had exercise 9.2 in that, correct? Do you remember? Exercise 9.2 problems we had already solved based on the theorem number 1 to theorem number 6. Fine. That is done. 9.1 is also done. So exercise 9.3 is based on the theorem 7 to 11. So inshallah, we will be solving the exercise problems as well as the example problems that are given in your textbook as well as the textbook, inshallah. Okay, chalo. Let's see the first problem that we have here. Okay. Okay, Laba, this is the first question, beta. Can you please read it aloud?
In figure A, B, C, D,
This is the
E.
figure, fine. AB.
AB is the diameter of the circle. CD is
Yes.
a chord equal to the radius of the circle. AC and BD, when extended, intersect at a point E. Prove that angle AEB is equal to 60 degrees.
Now what you have to prove is this angle AEB is equal to 60 degree. How would you prove this? They have shown something that you're going to join these points, okay? These points to the center O, so that you can just frame the radius here, and this point to this, so that you can form one triangle kind of figure in this way, right? Okay, so we just did two to three construction here. This point to this point, and this point to this point is joined. Fine. This is what the construction is done. Now, after joining this point, let's consider the triangle OCD. Okay, why did we consider the triangle OCD here? Is just take this bit up. OC is equal to CD, right? OC is equal to OD, right? Right?
Yes.
Yes, but in question they have given a CD is a chord equal to the radius of the circle. Okay, so we are drawing these two lines here. Okay, because they have told you that CD is equal to the radius of the circle, so CO is equal to CD is equal to DO, right? All these three lines are equal, right or not?
Yes.
Yes, if you draw it from the circle, radius of the circle to this point, now all these are equal. So this COD, what is COD now? Is it not an equilateral triangle?
Yes.
Yes, equilateral triangle. In equilateral triangle, all sides are equal. So COD, triangle COD is a equilateral triangle. Because, why is it so, beta? Because we already know that CD is equal to radius. What is radius? OC is radius. OD is radius, right? It is radius of the circle. OC is radius of the circle. OD is radius of the circle. And CD is equal to radius. So all if these three are equal, then it is an equilateral triangle. Do you know if the sides are equal, then angles are also equal? Do you know this principle in the equilateral triangle?
Yes.
Yes, right? If the sides in the equilateral angle are equal, then angles are also equal, right?
Yes.
Know this better?
Yeah, I know.
Yes. For example, if you consider one side as x, okay, let's see this. If you consider one side as x, for example, okay, where is it? Okay, all sides are equal. If you consider one side as x, then all of the sides will be x plus x is equal to 180 degree, right? Right, beta?
Yes. Yes.
Yes. X plus x is equal to 180 degree. 3x is equal to 180 degree. What is x equal to? 60 degree. So all the angles here in this equilateral triangle will be 60 degree, 60 degree, 60 degree. This is just for your reference, okay? You do not have to write this. It's just, I'm just telling you that all the angles are also equal here, okay? But now what you're going to prove is, you're not going to prove that this is 60 degree. The question here asked is, AC and BD when extended intersect a point, AC and BD when extended intersect a point, E, fine? Prove that AEB is equal to 60 degree. They are asking you to prove that this angle AEB is equal to 60 degree and not these angles, okay? These angles we already know that 60 degree. We already know that they are 60 degree, fine? So now what we are going to prove is, okay, what we are going to prove is AEB is equal to 60 degree. How do you prove this, beta? Just give me a hint. How can we prove this? Just understand how can we prove this. Do we not already know that these angles are 60 degree? Yes, right? These angles are 60 degree already, right? I've told you. Why is it 60 degree? Just now we have proved it, right? We know it already because in the equilateral triangle, all angles are equal to 60 degree, right, beta?
Yes.
Why did we prove this? 180 degree divided by 3 is equal to 60 degrees. So all of the angles in an equilateral triangle are 60 degree, 60 degree, and 60 degree. Just keep it as it is, okay? Just keep it aside. You just have to know this. So I'm removing this concept. You just have to know that angles in an equilateral triangle are equal to 60 degree. Okay, I'll just write it down here. Please take down in your book, okay? Angles in a equilateral triangle are equal, correct? They are equal. And equal to what? Equal to what, beta? Is it not 60 degree?
60
Yes, I just told you. Why is it 60 degree? We had just proved. Because x plus x is equal to 180 degree. 3x is equal to 180 degree. X is equal to 180 degree divided by 3. X is equal to 60 degree. So each angle will actually be 60 degree only. Okay. So angle COD or any angle, whichever you take, let's take COD is equal to 60 degree. Fine. COD is equal to 60 degree. But do you know something? Where is an arc here? Please tell me where is an arc here. I'll just erase this so that it will be easy for you. Where is an arc here? Is CD an arc? Yes, right? This is an arc. Correct. This is an arc. So do we not know this that something the angle subtended by this right? Do we not know something like that? The angle subtended by the arc at the center of the circle is twice the angle subtended by the same arc at any other point in the circle. Correct? Correct. Can we not take this point as B? Theorem number 7. We'll just apply the theorem number 7 on CD. Okay? The arc subtended by CD. Which is an arc subtended by CD? Is it not COD?
Yes.
Yes. COD is equal to twice the which did we consider? What did I tell you which to consider? Let's consider B as a point. Okay? This is a point. It is twice the angle subtended by the arc at any other point on the circle. So it is C twice the CBD. Understood? COD is equal to twice the CBD. Write it down or else you won't understand it. In the textbook, it is actually quite confusing for you. Okay, you won't get it in this way if you write it. If you won't write it, you won't get it properly. So COD is equal to twice the CBD. We know already that COD is equal to what, beta? 60 degree, right? 60 degree divided by 2 is equal to angle CBD. Correct? What is CBD? 60 degree divided by 2 is nothing but what is it? CBD is equal to 30 degree, right? Are you writing this down?
Yeah.
Please write angle CBD is equal to 30 degree. I'll erase this down. Please write it out. Theorem 7. From theorem 7, we just have proved that angle COD is equal to twice of angle CBD, which is equal to CBD is nothing but 60 over 2, which is angle CBD is equal to 30 degree. Fine. Write that. Take down that angle CBD is equal to 30 degree. Why did we prove angle CBD? Please tell me. Just to prove angle. The other angle, we are just proving this, okay? I'll tell you why did we take this, okay? Please write it down. Are you done? Have you written it all, beta? Written?
Yeah.
Yes. Okay. So we have this one as 60 degree. Fine. Fine, beta.
Yeah.
And this one as 60 degree. And this one as 60 degree. And what about this one? Again, the CBD, this small thing. This small thing is also 30 degree. Okay. If this small thing is 30 degree, can you not tell that this is 60 degree? This whole angle is 60 degree. We already know that, right? So where is our triangle now? Which triangle can we consider? This CBD is equal to 30 degrees over. Fine. Now we also know that angle ACB is equal to 90 degree. Why is it so? Can you please tell me? Angle ACB is equal to 90 degree. Can you please tell me why angle ACB is equal to 90 degree? This angle is equal to 90 degree. Previously, we just proved a theorem. It's not a theorem, it's a property of the circle. Before the theorem 11, I just told you one property of the circle. What was the property, Vita? Do you remember the property? It says that angle in a semicircle is always equal to 90 degree. Do you know this?
Yes.
Do you remember? The angle in a semicircle is always equal to 90 degree. So the semicircle matlab hota hai, there should be a diameter at the center, right? So whichever angle you produce from this diameter of the circle to any angle, for example, if you write this diameter and produce an angle from here till here, then it will be 90 degree only. If you produce this angle PQ and produce an angle, it will be 90 degree only. You have to remember this. So angle in a semicircle is always equal to 90 degree. So we will apply that concept here in the example problem. So you have to know why are we applying all of these, okay? So what are we going to apply now, Vita? It is nothing but angle ACD is equal to 90 degree, right? Right, Vita? Why is ACD equal to 90 degree? Is it ACB or ACD? ACB is equal to 90 degree. Please tell why is it so?
The
Angle
angle of semicircle is 90.
semicircle is equal to 90 degree. Okay. So previously, what did we do? Previously, what did we do? Do you remember? Previously, what did you prove, beta? Angle B, angle
That
CBD is equal to
60
CBD is equal to 30 degree. Fine. And we already know that all the angles in the equilateral triangle are equal to 60 degree. Okay. These things we know already. Now what we need to prove is angle through which we can prove the angle CED. Okay. Angle CED through which we can prove. Let's prove from angle BCE. Okay. Let's just see angle BCE. How will see angle BCE now? Angle BCE. To see this angle BCE, what will be considered? Please tell me. Is it not equal to 180 degree? This whole 180 degree minus, okay, angle ACB? Yes, right?
Yes.
Yes. So this BCE is nothing but 180 degree minus this one, right? So if we minus this, then it will be 90 degree, right? ACB, we already know that it is 90 degree. 180 degree minus 90 degree is equal to ACB is 90 degree. 180 degree minus 90 degree is equal to 90 degree. So angle BCE is equal to 90 degree. Fine. So here angle BCA is equal to 90 degree. Then this is also equal to 90 degree. Correct. Now,
Yes.
considering the triangle, this one now, this is 90 degree, this is 30 degree. Calculate the next rest. How to calculate the rest? Consider the triangle CBE. In triangle CBE, add up all the sides with a 90 plus 30, 180 degree minus 90 plus 30, right? This is how you are doing it. You're adding up all the side and subtracting it from the total of this. So 180 degree minus 90 plus 30 is equal to angle CE, CEB or AEB. It's same, right? This angle or this angle is same. So 180 degree minus 90 plus 30. What is 90 plus 30?
120.
Is it 120? Yes, 120, 180 minus 120. What is it?
60.
180 minus 120 is it? What is it? Is it not 60 degree? Yes,
Yes.
this is how you're going to find it out. Understood? Any doubts here?
No.
Do you want to write this down?
I wrote it down.
You wrote it down. Okay, that's great. Mashallah. So it is 180 degree minus 90 degree. VC is equal to 90 degree. Triangle CB, if we consider, we have to add up these sides. Angle ECB plus angle CBE plus angle BEC is equal to 180 degree. You have to write all of it is equal to 180 degree. So if you add up 90 plus 30 and then you send it here, 180 degree minus 120 degree, which is equal to 60 degree. So CB is equal to 60 degree or AB is equal to 60 degree. That's all. Fine. Okay, this
Yeah.
was an easy problem. And the
You
next
can
problem.
just use the washroom.
Yes, beta?
You can just use the washroom. Come.
Yes, yes, please.
Just come back.
Okay, no problem. You can just go.
Yeah, I'm back. Hello.
Okay, are you back, Vita? Yes. Okay.
Yes.
So we'll be studying the next problem. We have just completed example problem 2. That is, I have just mentioned it as problem 1. That is done from the textbook. So the next problem we are referring to is the problem number 2. That is example 3 in your textbook, inshallah. So it is, the question here is, Vita, ABCD is a cyclic quadrilateral. What is a cyclic quadrilateral, Liba?
When the vertices of the
Yes,
quadrilateral
really.
lie on the circle.
Where it is called as cyclic quadrilateral. Okay, they have told that ABCD is a cyclic quadrilateral in which AC and BDR is diagonal. Where is AC? This AC and this BDR, it's diagonals. Fine. If angle DBC is equal to 55 degree, where is DBC here, beta? This one, angle DBC is equal to 55 degree. Fine, this is 55 degree. Angle BAC is equal to 45 degree. Where is DBC is 55 and BAC is 45 degree. Find BCD. Find BCD. The whole this angle. Okay. How to find this? It is quite easy. Can you please tell me the tricks to find this? Very easy to find this. What can you do now? Any idea? If this is 55, what will be this angle? Or if this 55, what is the angle? If we have DBC is equal to 55 degree, and then
55 and 45.
yes, this is 55. Can we not see the alternate angles, beta? Alternate opposite angles here, because we remember in alternate opposite angles are equal. If this is 55, then which is also 55? Can you please tell me which is 55 as well? Just from the Z shape. Can we from the Z shape here? No, we cannot, I guess. No, we cannot. But we have one property, beta. Yes, we have one property. Which property do we have? Do you remember this is 55 degree? This is 45 degree. But we have one property. Please tell me which property do we have? There's the theorem number 8. Do you remember what is theorem number 8? The segments in the circle, these two segments will be equal, correct? The segments that is drawn, or what it is said, equal chords give equal arcs, right? Equal segments. The chords produce equal segments in the circle, okay? Do you remember theorem number 8?
Yes.
I'll just go back. What is theorem number 8? Read this aloud. Angles, okay. Angles in the same segment of a circle are equal. It means that angles in the same segment of a circle equal means, just look at this figure. This angle is equal to this angle. Already told, right? So we are applying this principle there. So in the example problem 3, we are applying the theorem number. And the example problem 2, which theorem did we apply, beta? This is equal to this. So this is 55. Then this is 55. Fine? Fine with it? So what do we write now? Angle B, or let's it be angle CBD. CBD is equal to angle CAD, which is equal to 55 degree. Why is it so? Please write it down. Theorem 8. Angle in the same segment are equal. So this is theorem number 8. Fine, beta? Okay. What is the next thing that you can decide? Angle DAB. Now please tell me what is angle DAB. We have 45 degree here, correct? It's already given. Fine. 55 plus 45. What is the angle DAB equal to? Is it not 55 plus 45? Yes. What is 55 plus 45?
100.
100. Now tell me what is the opposite angle? Total opposite angle. 55 plus 45 is 100. What is it? Angle A plus angle C is equal to what? It is already told in the cyclic quadrilateral sum of two opposite angle is equal to 180 degree. Fine. So angle A is totally 100 degree plus angle C is equal to 180 degree. Angle C is nothing but angle BCD, right? Angle BCD. Angle BCD is equal to 180 degree. Angle A is nothing but this is BCD and this is DAB. Angle DAB is equal to 180 degree and BCD is equal to not known. This is 180 degree in total because cyclic quadrilaterals are always the opposite sides of the cyclic quadrilateral are equal to Sum is equal to 180 degrees. So what is the angle BCD now, beta? Is it not 180 degree minus 100?
Yes.
Yes. So what is 180 degree minus 100? It's just the
80.
80 degree. So angle BCD is found out. Is it not easy?
Yes.
Very easy. Have you written it down? Should I explain to you again?
No, I
This is
understood.
equal to, understood. This is equal to this because of the theorem number 8. It's the theorem number 8 states that angles in the same segment are equal. Okay. And then this is given as 45 degree. 45 plus 55 gives you 100. So the opposite angles are equal to 180 degree. The sum of opposite angles 100 minus 180, right? 180 minus 100, which is equal to 80 degree, is the angle that is here. That's all. Okay, the problem number 3 in the textbook, it is nothing but problem number example problem 4. Okay, two circles intersect at 2 points A and B. Okay, I just forgot to mention the figure here. No problem. Let's just draw the two circles. Two circles. Okay, let this be two circles. Okay, they actually intersect at point A and B. This is given, fine. At the point A, this is a point B. Fine, beta. So the next thing, what have they told you? AD and AC are diameters to the two circle. AD, let's draw A. From A, you have to draw a line. Okay. Passing through the center of the circle, right? From A, you're going to draw a line that should pass through the center of the circle. Only then it is called as a diameter, correct? AD, and then they have told you AC. This is AC. Diameters to the two circle. They should be passing through the center of the circle to, so make it something like it should pass through center of the circle. Fine. Now again, just mark the point here as O, and here is something O itself, no problem. This is AD because it's told that first circle has AD and the second circle has AC. And the diameter is just two circles. Prove that the B lies on the line segment DC. You have to prove that this point B lies on the point. Okay, this B lies on the line DC. How will you prove this? You have to prove that this B lies on the point DC. By the figure, you can understand it is on the line. But how will you find that it actually lies on the straight line AB? How will you find that? Any guesses? This is a quite easy problem. Okay, I'll just draw. The first thing that you're doing is you're doing a construction here. Fine, Vita? You're just doing a construction that you're just connecting A and B. Fine? Aliba, can you hear me out?
Yes.
First construction, what you're going to do is you're going to construct one. You're going to just touch the line A and B. Fine. First thing, how to prove this? Join AB. Then what you're going to do? We already know. Do we already know that the angle in the semicircle are equal to 90 degree? Yes, right? This is a semicircle now. This is a semicircle. Okay, this is a whole circle. Fine. I'll just change the ink shade. Okay, this is a whole circle. Fine, beta. This is half of the circle. This is also half the circle. It's already told that if you have any angle touching any center, then it is actually equal to 90 degrees. So this angle is 90 degree, and the angle here is also equal to 90 degree. So 90 plus 90 is equal to the straight line, right? So DBC is equal to 180 degree. So DBC lies on the straight line. So B lies on the straight line BC. This is how you prove it, okay? So I'll just write the statements for you. Join AB is done. Then what you can write is ABD is equal to, we know that ABD is equal to 90 degree. Why is it so? Because of angles in the semicircle, right? Angle in semicircle. AIS, I'll write it down, okay? Just a short form. Angle in semicircle. Then what is it, beta? We also know that ABC is equal to 90 degree. Why is it so? Because it is also an angle in the semicircle. It is one of the property of the circle. Fine. Then, if you add up these two angles, then what is it? Is it not equal to 180 degree? Yes. If you add 1 and 2, then angle ABD plus angle ABC, which is equal to 180 degree. Fine. 90 plus 90 is 180 degree, which is nothing but we say that the B lies on the DC. Fine. Any doubts here, Laiba?
Yes.
Understood? No doubts, right?
Yes.
Do you have any doubts here, Vijay?
No.
No, that's great, mashallah. So we'll quickly see the next problem. I guess this is the last problem, an example problems, okay? Okay, this is the last example problem. Okay, Laiba, please read out this question, Vita.
Um,
Quickly read out this question.
prove that the quadrilateral formed, if possible, by the internal angle bisectors of any quadrilateral is cyclic.
Okay, what you have to prove that this is a quadrilateral, this is already given. Prove that the quadrilateral formed by the internal angles E, F, G, H should be a quadrilateral which is cyclic. How will you prove that it is cyclic? Cyclic ka matlab it should have angle F plus angle H is equal to 180 degree, E plus G is equal to 180 degree. How will you prove that? Do you have any idea how to prove this?
No.
Okay, we'll just start with this. Okay, the first thing that they have told you, prove that the quadrilateral formed by the internal angle bisectors. Okay, remember this, angle bisectors of any quadrilateral cyclic. So what one thing that they have given is that there is a bisectors here. Each angles are bisectors here. Now let's quickly start with each angles here. Let's start with one angle in the quadrilateral. Let's start with which is the angle that you will start with? Let's start with this or any angle. Let's start with the first angle, FEH. Let it be FEH. Okay, if it's FEH, then what is it equal to, beta? Any idea how we can do this? FEH is equal to what?
FEH will be AEB, right?
Yes. Why is it so? Vertically? Yes. AEB is equal to FEH because. Why is it so, beta? Vertically opposite angles are equal, right? Vertically
Yes.
opposite angle. This property we had studied in the triangles. Before the triangles, we actually knew this property, right? In the triangles,
Yes.
actually, we had to make use of this property that the vertically opposite angles are equal. So FEH is equal to AEH. AEB. FEH is equal to AEB, which is equal to, what is it equal to actually? What is AEB is equal to? We can just write AEB instead of this. So FEH, angle FEH is equal to A, to write the angle AB, what do we write? It is nothing but 180 degree minus what, beta? Angle A and angle B, right? 180 degree minus this two will give you this, right? So 180 degree minus EAB minus EBA. Are you understanding this? Have you understood this? Yes or no?
Yes. Yes.
Why did we write 180 degree minus EAB minus EBA? Just considering this triangle, beta. We are just considering this triangle now. To calculate AEB, how do you find AEB? Is it not angle AEB plus angle ABAE plus angle ABE is equal to 180 degree, correct? So to find angle AEB, what do we do? It is nothing but 180 degree minus 180 degree minus angle AE. We want AAB, so angle BAE minus angle ABE. Understood?
Yes.
So why is AB equal to 180 degree minus BAE minus AB? Because in the triangle, the total are 180 degree. So this angle is nothing but 180 degree minus these two angles, correct?
Yes.
Understood? Okay, so let's go back to the thing that we were proving. So it is nothing but first thing, what did we consider? Angle FEH is equal to AEH. Instead of AEH, we will write this triangle. Why are we considering this triangle? Because we want the higher quadrilateral, the bigger quadrilateral, right? From the smaller quadrilateral, we are going to prove the larger quadrilateral. So we are just going to prove in this way. So angle FEH is equal to angle AEB. Remember this. FEH is equal to AEB. So instead of AEB, we can write this, or instead of FEH, we can write this because this and this are equal, correct? FEH is equal to AEB. So can we not write this in all of the extra figures here? Yes, we can write it for others as well. For example, we can write it as F for FGH as well. You can also write it for FGH as well. For FGH, what we can write? FGH is equal to, please tell, angle DGE, right? DG, is it E? I think it's C. DGC, yes, it's C here. Which is equal to what, beta? It is 180 degree minus something, right? 180 degree minus, what is it? 180 degree minus angle GDC minus angle, this one, GCD, DGC, DCG. Okay, DCG. Understanding this? Any doubts still here?
Yeah.
No doubts, right? So instead of this angle, can we not write 180 degree minus angle, half of angle A plus B, because they are the perpendicular bisectors. These are actually the bisectors. Bisectors ka matlab hota hai, they actually divide it into each of this into equal parts. So instead of first one, we can write 180 degree minus half of angle A plus half of angle B. So half is taken out. This can be written in this way, and this can be written as 180 degree minus half of angle C plus angle D. Now what we do is we add up these two equations, this equation and this equation and this equation. Whenever you're going to add this up, how would you respond to this? Is nothing but you will actually get the answer as 360 degree minus 180 degree, which is equal to 180 degree. So what are we going to prove here is this, the opposite angle FEH plus FGH is equal to 180 degree. If the opposite angles are equal to 180 degree, then is it a quadrilateral? Yes. And the opposite angles are equal to 180 degree, then it is a cyclic quadrilateral from the theorem number. What is the theorem? 9, right? Is it theorem 9? No, it's 11. From the theorem 11, if the opposite sides are 180 degree, the sum of opposite sides are equal to 180 degree, then it is cyclic quadrilateral, right? Right, Laiba? Any doubts here? Angle FEH first we had proved. It is equal to nothing but 180 degree minus half of A plus B. The next one was 180 degree minus half of A plus B is done, C plus D. C plus D. Whenever you add FEH plus FGH, you will get FEH plus FGH. Then you will get at last the equation as 180 degree. Fine. Then we already know that from the theorem number 11, these triangles are cyclic if the opposite sides, sum of the opposite sides are equal to 180 degree. Fine, beta? Any doubts still here?